Assalamu alaikum. Hello, everyone. Thank you for joining the second series of the Learning Hub. My name is Lina Al-Atasi, and I'm the Head of Innovation at Oman Arab Bank. Over the next few months, we'll be running various workshops that are focused on promoting innovative thinking, enhancing your skill sets, and hopefully supporting you with your career journeys. These workshops will be announced via our social media pages and our website. You can register for as many workshops as you like, and they're open to everyone. Today, we're excited to be joined by Dmitry Doshchanyy from NNTC, who will show you how you can quickly build an AI or computer vision MVP and take it to the market. If you have any questions during the presentation, please send them in the chat window and Dmitry will address them at the end of the session. Otherwise, you'll have the opportunity to ask your questions live at the end of the session. Dmitry, over to you.
Thank you, Lynn, and thanks for everyone for tuning in for today's session. I run NNTC, which is a UAE-based software company, and computer vision is one of the focuses of NNTC and one of my personal passions as well. So I'm happy to share some of the learnings that we have had as a company in this computer vision journey, which is kind of a fresh trend in the AI field, and hopefully it will be useful to the ones who are kind of looking to transform the way the company works, or have a startup, or just kind of understand how this promising technology can be applied in the real life. So my today's session will not only be about how, but also about why, which is a more important question in my opinion. So NNTC is part of an international group of companies. We are basically a spin-off within a larger group, and we are focusing on the product development in the fields of computer vision and IoT and video analytics. And basically we have created a few product lines based on these core technologies, and we are promoting them in the region and even beyond the region as well. So what is a computer vision application? So basically the term computer vision is just something that allows a machine to see how it was understood initially. So basically a video camera is a computer vision algorithm because it can give a video feed to a computer. But now when they say computer vision, they quite often mean the machine learning that is coupled with the data acquisition mechanism to generate some insights based on the images or the video that computer is getting. And of course, this kind of cannot exist without some user interface, some ready-made software that is basically solving a particular problem for the organization. Because certainly if something can be done, it doesn't mean that it should be done, and it doesn't mean that a sophisticated technology has to be applied to it. So definitely computers work quite differently from the human brain and from the human senses. So computers see things differently than humans do. So we process immense amount of information without even noticing it, and the computer is basically trying to mimic the same steps that the baby has to go through when learning to identify the objects, because of course we are not born with the wealth of knowledge about the world that we are living in. And like in the early months and years, babies learn to recognize the objects, and okay, their parents tell them 100 times that this is a cat, and then they start to realize that okay, if the cat can be on a picture, the cat can be on a sign, the cat can be in the real life. Well, this is exactly what the neural networks are trying to make computers do. So basically identify the objects that look like a cat in different situations. However, for a computer, I mean, a toddler dressed up as a cat or a mug that is a cat is also a cat in a way, let's say, with a certain probability, it can be considered a cat. So when we are kind of getting the insights from a computer vision, it's never a definitive answer, because the computer cannot kind of make a final judgment. It can only say that, okay, with 99.9% accuracy, I believe that I see this object. And always there is some verification that has to be built into the software to make sure that it's making sense. I will touch that a little bit later. So the market for the computer vision is growing quite rapidly. This started, I would say, 3-4 years back, maybe, just because the accuracy of the algorithms and the power of the hardware that is available for the processing of the images and videos, like when reached a tipping point. So things that were 70% accurate now are 98 to 99% accurate. So for most of the cases where computer vision can be applied, it's much more accurate than the human eye. Accuracy is not the only thing when you are creating a piece of software, which we'll also talk a bit later. But clearly the market is quite sizable even now. It's over $10 billion globally, and it's growing to $33 billion in the next few years. And this is just for the core algorithms. But as we will learn, around those algorithms, multiple use cases, multiple apps can be created, which means that the kind of money that can be made on AI computer vision is higher than what we see. So what are the tasks? What can be done with the image recognition? Basically, the most popular one, I would say, is image classification. So when we are doing Google image search, we are doing exactly that. Then locating a particular object, identifying like a queue in the branch office, or identifying a license plate in the video stream from the CCTV camera. So this is something that AI is doing quite often as well. Then it is applied for image reconstruction. So really a much worse image can be enhanced using the computer vision. And a lot of that is happening in our phones every time that we are clicking the picture, because it's like a lot of processing and post-processing is happening in the background before the phone shows us the picture. It's doing part of the image reconstruction as well. And of course, in the videos, we talk about tracking of moving objects, which is quite important for the law enforcement use cases, for example, where we have to track a suspicious person as he travels around the city and identify the places where he could have visited in the past, or where he is actually at right now. So talking about the industries that can benefit from the image and video analytics, it's first is retail. The reason is that the cameras and the insights that can be derived from these cameras help the retailers know more about what is happening in the physical stores and know more about their customers. So when we are shopping online, the store knows a lot about us and understands end-to-end what is happening on the website, on the e-commerce platform. Whereas a physical store is a physical object, and things might be not in order on the shelves, in the cash area. And also it's hard to understand like who are the people who are coming to buy things from you. So unless they're a member of some loyalty program, you don't know anything about them except what they bought and how much they paid, right? So having the cameras look at what's happening inside the store can help to run the operations more efficiently. So there are quite a few things that can be done, for example, in a retail outlet, from the shelf recognition to understand if there are empty shelves and if the prices are aligned across the whole chain, to detecting the queues and alerting the management automatically if there are too many people in the store, preventing the shoplifting by creating watch lists of suspicious people, and the security can be notified when somebody who is suspected of shoplifting or maybe prosecuted for this crime enters the store, because I mean, probably he needs to be accompanied, not to have a temptation to do it again. And kind of understanding what is happening in the areas, how people are moving around, the heat maps, like what is happening in the loading and unloading area. So you can look at this as basically sensors that are placed in different areas in the form of video cameras that tell you what's going on, and if this is built into the software, advise you on what needs to be done, or just alert the human, and then kind of the manager intelligence is working to kind of make the decision about that. So second thing is law enforcement, which is one of the things that we have implemented ourselves in NNTC, because we have created our eye health and control software as a hybrid wearable and static face recognition platform. Basically, we have this wearable server that stores the database of watch-listed people. It can be some criminals, or it can be missing people, or any other persons of interest. And we allow the police officer to get the alerts directly in the smart glasses when like the person that comes in front of him is matched to the database and recognized. So basically the camera of the smart glasses or the body cam, they detect this person and then send the alert once this person is matched with the database of faces. So this is how it looks in the real life. It has been used to secure the public events. So the person having this wearable kit, he just stands and basically screens the crowd in the areas where there is not enough coverage by the CCTV cameras. And of course, this can be done with the static use cases, with the static cameras, and this is done pretty much in all countries around the world in one way or another. So obviously, China is very advanced in the video analytics, in the face recognition for the law enforcement, but this is happening in the US, in Europe, and in the Middle East as well, of course. Second thing is like there's quite popular and been popular for many years is the number plate recognition. So it's like from opening the barriers to the parking lots, to sending the speed violation and traffic violation fines. The idea is basically to detect a number plate in the video stream and then OCR it. And the kind of the challenge is that like there are a lot of types of number plates and they keep changing. So you have to constantly teach your system to recognize new types of license plates. But let's say the face recognition and the ANPR are quite developed areas of the video analytics and image analytics. When we talk about industry, also there is a vast potential for the computer vision, because similarly to retail, like you cannot have a physical premises, large port, warehouse, a manufacturing facility, refinery, fully digitalized, because it's a physical object and people are working with their hands there, and then there are a lot of machinery that needs to be controlled visually, and this is where the computer vision comes to aid. Here there is much less standardization, I would say, because in each industry there are specific areas, specific objects or cases that need to be tracked. And here, like in our personal experience, we do a lot of custom development, because it's kind of hard to do a computer vision implementation in the, I don't know, chemical industry, and then come to the car manufacturer and say, okay, look, let's just apply the same neural networks to what's happening in your premises, because like the all processes and how the facility look, everything is very different. So this is like one of the samples that we have created. This is the video analytics for vessels, for example. So the software detects the absence of protective equipment, like the life vest or the hard hat, and certain actions like a man falling overboard. They are also triggering an alert to the captain, because these are like this has been created for the service vessels, and the visibility of the crew is not that high, especially when there is active operation happening. And unfortunately, there were incidents and casualties in the past. And unfortunately, again, this is a big driver for the computer vision implementation in the industry, because of course, in every organization, there is industrial organization, there is health and safety. There are people whose only job is to make sure that things are happening in a safe way on their premises, and there is no downtime because of safety violation, and of course, there are no injuries or casualties. And this is another sample of the action recognition. So this is something that can be seen on the oil rig, where the person is working in a close proximity to the crane that is putting these pipes. The idea is that he shouldn't be putting in the pipes while the crane is moving, because he can get stuck and he can be hurt very badly by this huge moving crane. And every time that the computer vision algorithm sees that the crane is moving and the person is moving in the same time, not like the crane stops and only then the pipes are loaded, it issues an alert, and the person himself can be notified through a loudspeaker, for example, or through some wearable device that he has. And of course, his supervisor and the HSE team is also notified to kind of make sure that things are done in the right way, not in the, let's say, most quick way or most efficient as per the understanding of this particular person, because it's common knowledge that the safety rules are written with blood, and they have to be respected. So another topic that I will not touch in that many details is medicine, because obviously image processing in the radiology and other medical use cases is booming, and it's again, there are vast data that can be generated by the modern medical equipment. There are wearable devices, the MRT scanners, X-ray machines, etc., and kind of scanning them with the human brain and human eyes can be quite time-consuming. So basically, as a rule of thumb for any computer vision application, is if a person, an expert, is making some decision based on visual insights, based on some images or some videos that he sees, and the rules why he's making this decision, not the other one, can be can be put into an algorithm. It means that through the training of the computer vision algorithm, an AI neural network can be developed that makes the same decisions quicker and in many cases more accurate than a human expert. But it has to be broken down in a very, very simple steps. So, for example, in the medicine field, like I said, the X-ray scan and MRI scanning can be used by the doctors, or some kind of self-check apps are developed, so you can kind of show your own pictures, show your own results of those screenings to the app, and it will kind of give you the result, give you an AI opinion, let's say. Of course, we're quite far from that opinion being the only one that guides the treatment to the patient, but it's quite useful to check the simple cases and maybe remove the routine checks, let's say, of the healthy people from the radiologists that have to focus on more complicated cases in this field. So we've talked about the industries that can benefit from computer vision, and some things are already happening there. Why is this happening in the first place? So the need of optimization is one of the main drivers, because we're living in a world that is more demanding and that is quicker, and the insights generated by computer vision can help the organizations be more competitive and use their resources more wisely. So the cost of developing the applications and running them in production, all this hardware and cloud, it has decreased significantly. So algorithms are getting better, the hardware is getting cheaper, either on-premise or through the cloud, which means you can already get some meaningful insights and get real value from these algorithms applied in production. And this is one of the hyped topics, obviously. Everything that is related to AI and computer vision is the most developed and the most straightforward, let's say, case for AI as of now. So there is a lot of venture funding happening in this area, and it means that the market is growing quite rapidly, and there is also a lot of research and development that is happening in the field, and usually it's becoming available to the general audience quite quickly. And some of the blockers that are preventing it from kind of being more popular, being more adopted, it's basically the somewhat lack of understanding how to commercialize those algorithms and where it makes sense to go on this journey, which is still complicated and requires a lot of support in many cases while the project is running, because like what a lot of people still do not understand is that an AI application and computer vision application in particular is not a regular piece of software that, let's say, you install Microsoft Office and then it's yours, and you can install the updates, or you can stop installing the updates, but the kind of typing will be still there as the main feature and formatting. If you are doing a custom computer vision implementation for your organization, it means that the neural networks that are helping you to generate those insights need to be retrained. For example, if the protective uniform of the workers in the industrial facility changes, so they are starting to wear white helmets instead of orange helmets, or different uniform color, or they need to have I don't know, a harness hook as part of the certain activities, which was not the case before. All this new information needs to be fed to the neural network, and it has to be enhanced in order to be better in generating those insights. And I mean, still the 5G is not fully implemented worldwide, so getting real-time insights is a bit tricky in many cases. Still, it's kind of it's happening. The communications costs are going down, and 5G is getting adopted. So I believe this is less and less important of a criteria. So coming to the, I would say, the most valuable part of the presentation. So some of the tips and some of the lessons that we have learned and that are kind of being discussed in the industry of how to build the efficient computer vision applications. So first advice is try not to create something that doesn't exist. Because if you Google and you see that, okay, there is no way to identify a black hole with a camera of a smartphone, and nobody is doing that, it probably means that it's not possible, or it's super complicated. Like I said, there is a lot of research happening in the field, and a lot of startups are trying to apply the computer vision to all kind of problems in the world. So if you see that there is some activity, some early traction happening, then it's much better to focus on this area rather than kind of doing the Google search and getting zero relevant results, which means that you will have to do a lot of maybe even scientific work, which most startups and most organizations definitely do not want to do. And let's say the good thing about the current state of the industry is that a lot of algorithms are available now off the shelf. If you want to build a computer vision application these days, it doesn't mean you have to be a data scientist. You need to have certain understanding of the data science, but in many cases, just to identify what is the best algorithm for your use case, have the testing methodology in place and kind of go through some of the open source or some of the commercial algorithms that are available. Like I said, for example, there is hardly a need to develop a face recognition engine by yourself these days, just because there are so many face recognition applications, neural networks running on a mobile phone, in the cloud, on premise, with all kind of accuracy and all kind of price accordingly. So some can be used to, I don't know, identify a running person by just the video feed of the CCTV camera, something that is more used in the law enforcement field. But if your application just needs to recognize a person through the face, through the use of the selfie, and you are not doing something super confidential or something kind of prone to the fraud, you can use a much simpler algorithm and maybe a free algorithm as well, and it will still work. Same applies for the ANPR and really a lot of other object detection and classification cases. So just see what is happening in the industry, make some research, try to play with the open source or commercial algorithms, and maybe you will not need to focus on the core AI part, rather than like thinking on how to generate a business value and how to make a end software that uses the computer vision part in the smartest and the most efficient way for the organization. So maximum accuracy that you can achieve with your app is something that needs to be understood, because for some use cases, let's say the desired accuracy just cannot be achieved. So, for example, if we look a few years back, it's using face recognition for the law enforcement. 80% was, let's say, the accuracy, and this approach was not widely used, because, I mean, as a police, you are not likely to buy a pistol that only works 80% of the time, right? So you will use other means of solving the same problem until the technology gets more advanced. So now it got there, and for face recognition, it's super accurate, and it's much more efficient compared to any similar ways, let's say, of solving the problem of tracking the person of interest. But let's say some other ideas that you might have. Okay, you want to, I don't know, identify people on the moving train by clicking a picture of the smartphone. So find the best face recognition algorithm, take some of those pictures and videos, and feed it to the algorithm. If it cannot do it, then it means that you have to think about another use case and make the task a little bit less challenging for the algorithm. Because first of all, if the image is not clear, if the video or picture is not clear, and the kind of person cannot understand what's going on in this picture or footage, in most cases, computer will not help too much as well, or the accuracy will not be very high. There are different examples, but let's say as a rule of thumb, if you kind of look at the image that you want to analyze with AI and you can't figure out what's going on there, AI will not be able to do it too. Demoing, of course, when you are building a new piece of software or new use case inside your organization, it's always good to make some kind of demonstration with the tools, with the simplest tools that you can acquire. They can be less accurate than in the desired solution, and they can be even, let's say, non-existent as an AI, because what a lot of startups are doing, and I find this approach fairly reasonable. Let's say if you're informing the people about it, is using the actual people to work instead of AI. So, for example, you want to kind of recognize certain goods in the photos of the checks that people are sending to you in order to give them some reward as a retail chain. Yes, I mean, it's possible technically, but if you have if you're a brand and you're getting those receipts from all kind of retail chains, some of them will be in very different format. Some can be handwritten, some can be poorly photographed. And if you start this task by training a neural network, it might be a failure overall, because maybe the business model will not fly. Maybe this retail chain, this brand, will not make enough value from this idea, and they will prefer to increase the customer loyalty by doing something else. But if you kind of develop an application that just takes the photos, stores them somewhere on the server, and then you have people in the backend identifying this, it can help you deliver the end user experience, let's say, and see if it flies or not. If it flies, then again, you can make a prior research and see how feasible is this task technically. So if in theory this neural network can be developed and something similar has been developed in the past, then you can go to the step 0 and use the human intelligence as a substitution for artificial intelligence early, when you don't have a huge workload on your software, and when you're still testing if it will be a feasible commercial product. All machine learning is not 100% accurate, and computer vision as well. I told this in the earlier slides. So some cases will be missed, and you have to have some rules for handling those exceptions. So think of a chatbot, for example. If you're having a voice recognition chatbot, there is always have to be an option to talk to a human operator, because maybe the chatbot cannot understand your accent, or the answers that it has been programmed to give are not relevant for your situation on some reason. So you have to always have an option to talk to the human if the case is more complicated than the program is trained to recognize. And something like that has to be part of the computer vision application as well. So if you are not kind of getting enough accuracy on this particular picture or this particular video, what happens? It shouldn't ruin the overall user experience, because like I said, the images and videos can be of different quality. It can be day, night, fog, backlight coming to the camera, users taking photos with the shaky hands on all kind of smartphones, some of them with better cameras, some of them with worse cameras. So sometimes you will get misses, and this has to be incorporated in the application. So you have to know what you will be doing when this thing happens. So this brings me to the end of my presentation. So the key takeaways are on the screen, and I don't want to repeat them because I have just set it out on the previous slide. So just take a look yourselves. And as maybe maybe some of you were expecting this session to be more technical. whereas I try to talk more about like why to develop computer vision application and what are the use cases and how to make a business and get some return on investment out of it. Of course, we have a much deeper, much more technical people in the team. And if you're looking for more applied knowledge, so, okay, how do I start with developing my computer vision application? How do I start learning Python for the data analytics and AI programming? Please drop me a note. You can find me easily on LinkedIn, and I will share some of the materials that our data scientists, our AI guys are using, and we'll be happy to talk every once in a while and help move the computer vision industry forward together. Thank you very much for listening, and I will be happy to continue the conversation and answer some of the questions that we have in the chat.
Thank you, Dmitry, for a very comprehensive presentation. I'm very impressed by the use cases that you've provided across all industries. Thank you very much. I hope that was helpful for all our participants. We'll now open up the opportunity for participants to ask questions. If you have any questions, please just raise your hand or type them in the chat window at the bottom. In the meantime, while we receive participants' questions, Dmitry, perhaps I can ask you, in terms of the industries that you mentioned earlier and the use cases that you've covered, where do you see are the biggest opportunities for innovators who are looking to develop computer vision solutions in this region?
I would say that they are retail in a wide understanding of this word, because banking and insurance use cases for computer vision are quite similar to the retail. It's the VAT customer recognition, it's the KYC identification, it's fraud prevention. So this is something that I would say on the easier side of the development, and the penetration in the retail outlets and similar organizations, including government, is not that high yet. I mean, all for the industries that I mentioned, they are present in the region. Of course, there is a huge industrial and petrochemical facilities that are striving to be the best in their field. I mean, the giants like Saudi Aramco and ADNOC, they're trying to be the number one, not in terms of the output only, but also in terms of doing things in the most efficient and the most green way, which brings a need for the optimization, and some of this optimization can be achieved through the computer vision. So I would like give a general advice: look for the industries that are going through the changes, because if it's super stable, if there are no challenges, if the money just keeps flowing regardless of the market conditions, COVID, etc., then it's not likely that this customer or this organization will invest either in-house team to do something smart and complicated, or pay for the solution that is doing same for them. So yeah, somebody who is kind of going through the transformation, going through the market disruption, can benefit a lot from the AI and computer vision.
Great, thank you. That's great advice. And obviously there'll be a lot more bought into implementing these solutions than other organizations are perhaps not as into digital transformation as some. There's a question in the chat window from Shabir. Does this application get integrated with any available hardware devices, or is the hardware packaged with the application?
I'm not sure exactly what is referred to as the application, because I didn't talk about particular pieces of software a lot. So maybe Shabir can clarify what exactly he means here. But as like in general, so how can AI be implemented? In most cases, it's implemented as a piece of software that runs on the commodity chips, either CPU or GPU. So it's basically buying the available hardware, the most cost-effective and the most powerful. I mean, the power that compute power that needs this use case, and installing the software that runs computer vision algorithms on your operating system of choice. In most cases, I mean, in many cases, I would say it's Linux, but it can be Windows as well. So basically, the complicated part of computer vision is mostly in the software. However, for some specific use cases, sometimes they make hardware chips that deliver certain certain AI, certain neural networks functionality on board. So if we're talking about like mobile devices, something that has to be very lightweight and consume less power, then the hardware manufacturers, they do put in the algorithms into the silicon every once in a while. But again, this is mostly done by the organizations that have significant financial and technical resources for that, because definitely developing hardware and launching a hardware startup is much more complicated compared to doing just software. I hope that answers the question, and if not, dear Shabir, please clarify.
Thank you, Dmitry. Shabir, if you'd like to add anything to your question, or if you'd like to follow it up, please raise your hand and we'd be happy to enable your mic. Okay, any other questions from our participants? All right, great. Thank you very much once again, Dmitry, for joining us and for this very insightful presentation. We look forward to hosting you at our upcoming innovation workshops in the near future. We'd also like to thank all the participants for joining us today. We hope that you found this workshop informative and insightful. If you'd like to refer back to this workshop, please visit our YouTube page, Oman Arab Bank's YouTube page, for videos of all the workshops that we've been running over the last month or so, and the ones that we'll be running in the near future. We look forward to welcoming you back at our upcoming innovation workshops. All of these are announced, as I mentioned earlier, on our website and social media pages. We hope you enjoy these sessions, and thank you once again. Have a lovely day. Thank you, Dmitry.
Thank you, Lynn, for the opportunity to speak, and thanks for everyone who is eager to learn about computer vision. Good luck to all of you.
Thank you. Thank you.
Till next time. Bye.
Bye.